going to be going over exam 3, starting with number 1, which is about the golden ratio. Now, this setup here, we have 3 golden rectangles. You're given in the problem that this is 13 here. So this is the, looks more like this. So you're given that this measurement here is 13. Since this is the long measurement of the golden rectangle, this is not going to be 13 times phi, but this is going to be 13 divided by phi. Alright, so from here to here, we get that short segment by dividing by 1.618. We know that each of these are going to be 13, so this measurement here will be 26. And this is the short measurement of the golden rectangle, so this longer measurement here is going to be 26 times phi. So when you either take these individually or you take all of their elements together, one way to think of this is going to be 26 times 26 phi plus 13 over phi, so these two together, 26 phi plus 13 divided by phi all the way across. That's going to be around 1302. So that's the answer I was looking for the first one. For the second one, this sequence is arithmetic, meaning that we're going to be adding or subtracting some amount at the same time for all of them, and we're adding 0.618. So I tried to be a little tricky with this one, but this one's arithmetic. For number 3, this has cylindrical coordinates of 3 pi over 2 and z is -2. I think it's sometimes helpful to draw these in 2D space first. So if theta is equal to 3 pi over 2, that's going to be putting us pointing in this direction here. And we're going to go out 3. And then z is negative on there, -2. So in 3D space, if we think of this as being the negative y direction, it's kind of hanging out here on the yz plane, and then we go down 2, so our point is actually down here. X is 0, y is negative, and z is also negative on there. So x is going to be 0, y is negative, since we're working in this negative y direction, and that's the answer for A and B. For number 4, we have spherical coordinates. So theta is going to be equal to pi, phi is pi over 2, and rho is 3. So when we are trying to plot this point, I'll start with theta. So theta is equal to pi, which means we're pointing in the negative x direction. If you want to draw it in 2D space, we're aiming our telescope, so to speak, in this negative x direction. That's going to look like this over here. So pointing in this direction, the negative x direction. Phi is pi over 2, which means that we're not looking up, we're not looking down, we're just looking straight ahead in that direction. And we go out 1, 2, 3 units. So that means that we're kind of hanging out on this negative x-axis here. So is y positive, negative, or 0? Well, it's not moving that direction or the other. It's going to be 0. You can see that in the 2D drawing as well. Y is 0 when we're pointed in this direction. And Z is also 0, right? We're not looking up or down. Due to this, we're looking straight ahead for that. For number 5, if we think about what's happening with U and V here, this is labeled X and Y, but we really know that these are actually U and V on here. So if you used X and Y, that's, I didn't mark any points off, but we should be talking about these as being U and V. Okay, so when we multiply, so I'll just recreate what's going on here. We multiply by 4. We're adding 7 to this, and cosine multiply by V, and then when we add this on there, we plug that into Y. Okay. So I'm just thinking about what's going into each of these. That gets connected there. Just thinking about the inputs and outputs of this. When U goes into this, what comes out of this is 4U. And then we'll add that at the end step here. Going along this path here, what comes out of this one is U plus 7 after we add it. And then after we put that into our cosine, we get cosine U plus 7. And then that gets multiplied by V. So this is going to be V times cosine U plus 7. The very last thing that happens is we add those two values. So that's going to look like Y equals 4U plus V times cosine of U plus 7. So we really want to think about these as being inputs and outputs for each of these little machines that either multiply or add or do something else. For number 6 is a drawing exercise. I'll draw this in 2D first. I'll suggest you do the same thing for each of these. So if R is in between 0 and 3 and theta is in between 3 pi over 2 and 2 pi, then 3 pi over 2 is pointing in this direction and 2 pi is pointed in this direction, so it's going to be this section here. I think it's useful to start thinking about this in terms of this is negative y traveling towards positive x. So negative y direction and positive x. That way when you're drawing this, here's positive x along here, and negative y is going to be just traveling in the opposite direction as the positive y-axis. If we go out 3 units, 1, 2, 3, in each bit here, we see that this is the quarter of the circle that's covered. All right, the rest of it be around here. But this is the quarter that's covered. And then from each of these units, we want to go down, since z is in between negative 2 and 0. We want to go down 1, 2 units. 1, 2. And so we get it to look like that. We also had a graphing in rectangular units. This one I gave a lot of half credit out for this one, just because I saw a lot of things that were close but not quite. So x was in between 1 and 3, y was in between -2 and 6, and z is in between -4 and 2. Just marking these off here. Right, something like that. When we mark x equals 1, that's going along this line here, and x equals 3, so that was there. And then for -2, we need to mark over in this direction, over here. These lines need to be, we can't just make them kind of connect down like this. I saw a lot of people connect like that, so that's not right. We want to do a line coming off of this -2 like that, and then 1, 2, 3, 4, 5, 6 coming across like that. So it should be, everything should be parallel with this x-axis here. So this rectangle, all right, everything in here, I just highlighted, that's what that looks like on the floor, where, or the xy plane, where z is equal to 0. But z is not equal to 0. It's in between -4 and 2. So I'll show you the incorrect thing that a lot of people did. They know that they need to go down 4 units, so they would count 1, 2, 3, 4, and 1, 2, and use that as their kind of top and bottom, and then draw it, you know, like this. So that's not what where we want to measure z. That's just sort of where it's happening on the z-axis, but that's not where we want to measure our z-coordinate. Where we actually want to measure it is looking at each of these points here. So we can picture this rectangle. We want to move that one up. 1, 2, 1, 2, 1, 2, 1, 2. That's what the top of our rectangle looks like. And then for each of these points, we also want to go down 1, 2, 3, 4, 1, 2, 3, 4, 2, 3, 4, and 1, 2, 3, 4. So that rectangle down here, this is where the bottom of this should be. So notice that's very different from kind of if you measure from the z-axis. Right? So anyway, the final product should look something like this. So I needed to see, did you extend this out far enough in the negative direction in the y, and did you also extend this down in the z on there? So just a general tip, build this, start with x and y, build this rectangle like that, and then move it up and down from those 4 corner points to give yourself your final shape. For number 8, this was y equals cosine of theta minus 1. Our normal cosine curve, right, cosine of theta looks like this, where it starts at 1 and goes down to -1. So this -1 here, that tells you that you need to take this entire curve and move it down 1 unit. So if you want to start with that cosine curve, I did need to see kind of where these are happening. All right, so this is pi over 2, 3 pi over 2. So you can either start with this and then move everything down visually, right, like that. But I think what I'll show for this one is just showing what it looks like when you move down here. So this goes from 0 out to down to -2, and then its normal cycle is from 0 to 2 pi. I saw a lot of people just decide to put this into the graphing calculator and didn't put any measurements anywhere around here. So you do need to know what cosine looks like, where it's going, how this changes it. So that's what I'm testing there. For this next one, I wanted to graph. So I'll start off with this 3. So the 3 modifies our sine wave that normally looks like this. Goes, instead of going from 1 to -1, like a regular sine wave does, it goes from 3 to -3. So it completes that same cycle. Over there, this 1/2 there, a lot of people thought that this did the same thing as 2, so we looked at sine of 2 theta. That made everything faster, so that kind of compressed it this way. But sine of 1/2 theta, that's moving half as fast. So rather than taking a full 2 pi to go through one lap, it's going to go take twice that long, so 4 pi. So this would be 2 pi, 3 pi, like that. So you would take all of your normal measurements, right? Normally it goes to 2 pi for sine. What you would do is just multiply or divide this by that 1/2. So anyway, when this is 1/2, this is twice as slow or half as fast, if you want to think of it that way. And so it takes twice as long. Last one is 10. Again, theta starts here and moves counterclockwise. All right, so on my xy plane, pi over 2 is up here, and 3 pi over 2 is down here. So everything gets filled in over on this side because we are moving counterclockwise. So we start at pi over 2 up here, and then we move out to 3 pi over 2, which is -y. So this was everything. Just make sure, in case you didn't on the actual exam, make sure you fill in everything on here so I know which part you're talking about. But yeah, those theta measurements, remember, theta equals 0 over here, pi over 2, pi. This is 3 pi over 2, back to 2 pi. All right, hopefully that answered all your questions, and good luck studying for the final. I'll see you then.